video simulator.
Okay.
It is a real disease.
You know, I actually got that on camera, right? Right now we're measuring this.
Measuring boards using other boards for boards while we cut with boards.
Yeah. Sorry, Jackson.
If I could say the word board,
Yeah. Now we're about to cut it. This is for the vertical struts.
Hi, Fly. Alright. Well, the spring, I mean, this is the twine acts as a spring for the catapult. So it's the force that exerts that when it is tightened, it creates tension and it makes the catapult go, and it makes it throw it hopefully really far.
Here is the crank for tightening the string to make sure it has more tension and so it can actually launch it. Then over here is the upright with the crossbar that is used to stop the arm up so it can actually launch something and not just go around.
Yep. And the last piece is the arm and the connection that actually makes down to this wheel section right here that holds it steady while it's still being ready to be launched by the twine. It can create more lever action to get more tension within the twine or rope or whatever you're using for the spring. And then when you're ready, normally the rope is just cut and then it is let to fly, or you could have another release mechanism attached to it. Alright, the first part of the device to talk about is the twine spring. That is the part of the device that runs along the two boards made of twine that the lever arm is attached to. It is also the fulcrum of the lever arm, as the lever arm is not attached in any other way to the main catapult. It is tensioned by the two twine cranks that are made up of dowel rods on either side of the device. The support beam, or beams, that run in between the two sideboards are just to keep the boards from bowing inwards too much, because the twine spring is pulling them towards each other and nearly breaking them at some points. The stop bar at the top is, exactly as its name implies, meant to stop the arm so that the payload can keep going without any obstruction from the lever arm. And the upright support beams are just to keep the stop arm from breaking upon impact with the lever arm. And the counterweight, otherwise known as me, was used to launch it when we could not generate enough twine tension to launch the payload without destroying the boards.
The problems were as follows. The arm was just too long. It was too heavy and too long for the spring to tension to actually launch anything. And the launching box at the end of the arm was just really heavy, and so it added weight to the already heavy arm and made it so it wouldn't actually go up with the 8-pound weight on it. The base was too long. It was just 8 feet was way too long, and so we needed to shorten that to maybe 6 feet or 5 feet or something, because it was just way too long. And the thicker weight and the side, and also the sideboards, those 2x8s on the sides, really needed to be thicker because they were bowing inward and kind of break. The wood was literally cracking when we turned it, and that was not good. So we couldn't turn it as much as we would like to.